Rectifier diode is a semiconductor device that allows current to flow in one direction only. So if you look at the current and voltage curves over here, basically when it comes to forward voltage, it allows current to flow. This is the forward bias. And come to reverse, it doesn't allow current to flow. Basically, it blocks the currents at a defined breakdown voltage. So this is basically how the rectifier diodes work. It works in unidirectional current flow, as mentioned just now, and it offers high current flows, as well as it offers low forward voltage drops. These are the examples of AC to DC conversions. So in AC or to DC conversions, in electrical applications, you will find rectifiers being used for rectification purpose. So some of the examples such as power supplies, battery chargers, UPS, DC motor drive, welding machines, you could find rectifiers in AC to DC conversions. So AC to DC conversion basically is to convert the AC main voltages to the DC voltage, or you can say the alternating currents to direct currents. So it applies to all the power supply, battery chargers, up to the welding machines. Basically, there are 4 types of rectifier diodes. So we have the standard recoveries. We also have the fast recoveries and super fast recovery, as well as Schottky barrier rectifiers. So in terms of switching speed or the recovery time, you could see standard recoveries offer the slowest among the 4. And we have fast recoveries is in the medium range. Super fast, we're talking about less than 150 nanoseconds. And Schottky barriers rectifiers, basically we could neglect the recovery times, but in actuals it is less than 20 nanoseconds. So if you look at the cost effectiveness or the voltage range offered, standard recoveries, fast recoveries, and super fast recoveries offers a very high voltage. But for Schottky barriers rectifiers, the highest voltage it could comes to is about 300 volts. So the advantages or the benefits of rectifiers is basically it gives you a simple design in your circuitry, and another is, of course, is talking about cost effectiveness. So let us look at the examples such as ESD protections. So in ESD protections, we could use 2 simple Schottky barrier rectifiers to achieve the protections of over voltage. So for O-ring, instead of using MOSFET of IGBT, we could actually use 2 rectifiers to achieve the same functionalities for the O-ring applications. In terms of rectifications, so if customer choose not to use the bridge rectifiers, they could actually use 4 pieces of diodes or the rectifiers to achieve the same results of full rectifications, or they could use 2 pieces of diodes to achieve half rectifications for AC to DC conversions. So you can see among all these applications, it gives you the benefits of simple designs as well as cost effectiveness.